Welcome to the Notes and Solutions for day 23 of our GCSE 5 a day. Well, this is a question here where we need to read the scale of this speedometer in the car, and then we've got to answer a question. So we're told that the speed limit is 80 kilometers per hour. We can see 80 there on our dial. That's kilometers per hour. And we're saying how many kilometers per hour slower than the speed limit is the car traveling. Well, this is the arrow here is telling us what speed the car is traveling at. And so our first task is to be able to read this scale here. And we see exercises like this in life an awful lot, in measuring jugs, for example, where not every mark has a number attached to it. So we have to work out what these steps are. And our first instinct is that this is 1. So it's sort of 61, 62, 63. Well, that can't work, can it? Because that's 70. So it's clearly not going up in ones. And now we're in this point here. Well, that's halfway, isn't it? So what's halfway between 60 and 70? Well, that's 65, isn't it? So we are traveling at 65. The speed limit is 80, and we're asked how many kilometers per hour slower. Well, that's a smaller speed. So this is how much slower here. Well, that's a subtraction calculation that we need to do. 80 take away 65. 5 is bigger than 0, so I'm going to borrow a 10 from my tens column. 10 take away 5 is 5. 7 take away 6 is 1. So my answer here is 15. Now, we were asked how many kilometers per hour, so fine, if you want to give those units, that's okay. But because I didn't say how much slower. If I'd said how much slower, then your answer would have to be that one. But because I've said how many kilometers per hour, then just 15 is okay. If you'd answered, by the way, in kilometers, then that is going to be wrong, because that's not a speed, that's a distance. So a couple of nuggets here to try. If you want to practice reading scales with funny divisions like that, then that's a good one to try. Also, some more worded questions like this, nugget 3.03. Okay, we've got a nice solid percentage increase question. So Max earns £220 per week. He's given an increase, so that means we're adding something. And when we've done that, we end up with his new wage. So we need to work out what this number is. Well, we're told his increase of 10%. So he's given an increase of 10%. So we need to be able to work out what 10% of 220 is. Now, 10% as a fraction is 1/10. And to find 1/10 of something, we're going to divide by 10. So let's have a look at the place value here. Ones, tens, hundreds. If we're dividing by 10, everything is going to move one place. So 22.0. So the number that we're going to add here is 22. So he starts with 220, increase 10% of that, add these two together, 242. Let's remember our units. So century nuggets to practice here. Finding 10%, 7.04. A few percentage increase questions, 10.01. Good solid practice for you. Now, students quite like these questions. These are two-way tables, but I'm going to make sure that I show you here how we always have to check that we've done our work right, because it's possible to do this so you can be sure that you are right. Now, they're called two-way tables because we have two different parameters. The first one is language here, and here we are splitting up our students by gender. So let's see what we've been given. There are twice as many boys as girls studying French. The total number of students is 50. Now, what I'm going to add in straight away is I'm going to add in an extra column of boxes for totals here and an extra row, because totals are important when we're doing two-way tables. And in fact, we're told that the total number of students is 50. Now, this is this big grand total in the bottom corner here. So that's done. I've put that in the answer. What we're after, by the way, is how many boys are studying German. So this is the cell that I'm really interested in. So what's our first sentence here? There are twice as many boys as girls studying French. Well, studying French is here, and 14 is twice as many as whatever this number is here. Well, if 14 is twice as many, then this number is half 14. Half of 14 is 7. So this number here must be 7. So we've now entered all the information that we've been given. So it's a question of what can we now work out? Well, if 14 boys and 7 girls study French, then the total here must be 21. If 7 girls study French and 7 girls study German, then in total there must be 15 girls. If in total there are 15 girls and all round there are 50 students, then that means we can work out the number of boys. 50 take away 15 is 35. So there must be 35. Now, if I know that there are 35 boys, 14 have studied French, then I can now work out this gap here. 35 take away 14 is 21. Now, you might say stop there because I found the answer I wanted, but I want you to carry on and fill in this final box. And the reason is that we can work this out two ways. We can either work it out this way by adding 21 and 8, which is 29, or we can work it out using a row. 50 take away 21. Well, that also comes out as 29. Now, once those come out the same, then that is my check that I must have done my calculations okay. So I can now be happy that my answer of 21 is correct. And if I want to do more practice on that, and it's a good skill to be able to execute nice and quickly in your exam, then the nugget to go for is 50.01. Question 4. We've seen quite a few examples in recent days of collecting like terms, and the reason that these appear quite regularly in your 5 a day is that students do make mistakes whenever minus signs or negative signs appear in these exercises. And the key is to understand that this plus sign relates only to the term 5k. This plus sign here relates only to the plus h, and our minus only relates to the 3k here. Now, this isn't always going to help if there are lots of minuses in here, but what I'd like you to do is to just try visualizing what's going on. So I've replaced my H by horses and my K by kangaroos. And this is what I mean by collecting like terms. that we're going to deal with the horses first. If I start with 7 horses, I add a horse, then I've got 8 horses. If I start with 5 kangaroos and take 3 away, I've got 2 kangaroos. So what have I got altogether? I've got 8 horses and plus 2 kangaroos. Please practice this. It's an important skill to be able to execute properly. Nugget 17.04 is the one to go away and make sure you get 100% on. Okay, question 5. Now this is quite a naughty question to have included in here because you'd be unlucky to receive this in your foundation tier exam. So a recurring decimal, these points at the top here indicate to me what a recurring decimal is. And what it means is the pattern that starts with the first one and ends with the second one is repeated forever and ever and never stops. Okay? Now, the way I'm going to deal with this is a clever piece of maths here. So I'm going to call this number here n, and what I'm going to do is I'm going to have a look at what 100 times more than this looks like. Now, to multiply by 100, we're going to move all our digits 2 places bigger, 2 places to the left. So our 100n looks like 81.818. So we've got the same recurring decimal after the decimal point. And the only thing that's different is that here we've got a 0 and here we've got 81. So my clever piece of maths is that I'm going to subtract my n from here. So I'm going to take my 100n and I'm going to take away n. So that leaves me with just 81. So 99n equals 81. So n equals 81 divided by 99. And there we have it. I've been able to describe my number as a fraction. We were asked for it in simplest form. Can we simplify this? Well, hopefully we can see that we can both divide top and bottom by 9. 81 divided by 9 is 9. 99 divided by 9 is 11. And there we have it. Our fraction in simplest form, 9 over 11. You might need to ask your maths teacher to send you this nugget because you may not be able to find it in your course, but the one you're after there is MH51.04. But isn't that an elegant piece of mathematics to somehow make those infinitely recurring decimals just disappear like that and come down to our single integer 81? Okay, well that's a nice piece of maths to end our 5 a day with today. Keep up your hard work because we are getting towards those exams.